I'm just going to continue with my previous video. I think in the previous video I just talked about why are we studying about or learning this module. Yeah, probably I think I want to mention few of the things. So like apart from your reaction, why are we studying these different unit operations? I think I already said some few reasons, and there are few other things like normally if you are doing anything at like at plant scale, like several thousand liters, like if you do some experiment in a lab scale, for example you are doing something at a, say like 1 gram of your product, obviously you can use maybe like a half a liter of solvent, and then you can throw the solvent, and then you can go for the next reaction with a fresh solvent. So that's what I do in the lab. But in industries, when we are working with 10,000 liter 30,000 liters, then that time we have to try to find the ways to recover the solvents. Say imagine if you are purifying a paracetamol, everybody knows about this drug. So if you're purifying paracetamol using isopropanol, for example, then if you are doing that in a like a 20,000 liter reactor, we cannot dispose all the 20,000 liter solvents once you finish your crystallization. So you should find some ways to recover your solvent, and normally for that we will go for some unit operations. So one is like a distillation that comes to my mind, and then normal. So these are the things you should have some idea about, and that's why we are studying those topics about different unit operations in this module. So that's one good reason you are learning them in this through this module. And I think that's enough for the moment. Then regarding the how I'm going to assess this module, I think this is really important, I have to mention. So final exam will be for 39.5 marks. This might look a bit weird, but we have to follow some rules in the university. 39.5. And then what else? Lab 30 marks. And then lab 2 plus assignment. So this is going to look like an assignment. It won't look like a laboratory report. It shouldn't look like a laboratory report. Lab 2, it is an assignment in fact, but since you are going to solve some new experimental data, I call it as a lab plus assignment. So this is an assignment. It deals with PAT. So lab 1 is 30 marks. This is your super pro design. Last year the students got very good mark with this super pro design project. Both engineering students and also the students who do not have an engineering background, they solved it. Then lab 2 plus assignment, this is a part 2. So this is something new I'm introducing this year to the students for this module. Anyway, this is part is, if you go to your book of modules, you will see you have to learn about this process analytical technology. So part tools. So I will post the instructions separately in Sulis, how to write what is expected. So and this is coming back to lab 1. So what is this about? Like I will record a video using super pro design, and and then I will tell you how to use the software, how the graphical user interface looks like, how you drag and drop different unit operations, how do you connect those different unit operations, how we load the reactants, how do you define the reaction, it's an equilibrium reaction or a conversion reaction, how do you enter the kinetic constants inside the reactors, and how much mass that goes inside, how do you define the number of mass, or if your feed contains different components, then how do you enter the mole fraction or mass fractions of those different components in the feed, or how to perform a mass balance calculations. Everything I'm going to record. Yeah, I will. It's a simple video. I will put one reaction and followed by a filtration unit. That's a very simple thing to do. So, and based on that knowledge, and then I will give you a full tutorial book in your hand, and then I'm going to give you some topic, say for example manufacturing of citric acid. So you have to use that software, and then you have to design a plant like unit operation 1 that goes somewhere, filtration unit, say some gravitational settling tank, something comes out here, or maybe you take the product out, say put some plate and filtration column, followed by we are going to dry them, or maybe take the product, do some crystallization, and then take the pure product out. So these are the things you have to do using a SuperPro design software, and then you will make a very good report out of that. So you will get 30 marks, and you are not going to get 30 marks just like that. Yeah, for that you have to work a lot, you have to make an extremely good report. So you are taking 60 marks before sitting in the final exam, so you should do the justice for that. So it will be worked, you will work in groups, so you must engage with your group members, so that way this project will become easy. If you work alone, it's going to be a nightmare. Yeah? So it's better you work together, talk with each other, and then just to get some idea about the project. And you must tell to me if some of your members are not engaging in the project, you must say it to me immediately through an email, so I will keep a record on that. So everyone should contribute, and at the end of your report, I expect you to tell, like if you have 4 members in the group, you must clearly state who contributed what. Yeah, so don't mention that all of them contributed equally. It may be the case, but still there will be some special effort from each person. Yeah, some person might have done some literature survey, some person might have solved some key problem in one of the unit operations, somebody might have did some troubleshooting, like when nothing gets converged in the flow sheet, then someone might have figured it out how to solve that problem. So you have to tell that to me, and it means like not via email exchange, but in your report you have to state it clearly, your individual contribution and your collective contribution. So that should be you must include that in your final report. Yeah? If I don't see that, I will take some marks out from your final grade. Yeah, final grade means, I mean, out of this 30 marks. Or maybe another example is like a purification of an active pharmaceutical ingredient. Maybe you can use a crystallization technique, so you will put a crystallizer, and then after that you might put some filtration unit and so on. Yeah, so try to make a decent report. It should be very good report. It's 30 marks. 30 marks means it's a big number. Yeah, so you should work a lot for this lab report. So I will try to record a video by this Saturday or Sunday, and then I will upload it in Sulis, and then you just watch it, and then by whether I'm going to upload this week or not, I'm going to separate the groups, and then I will assign the projects for you. So soon you will see that in the Sulis, probably by the weekend or maybe by Monday. Yeah, next Monday. So you get 30 marks from this lab, which is based on SuperPro design project. Last year I gave only 20 marks to the students, so this year I'm going to put the number a bit high. So you will get 30 marks for lab 1. I don't even like to call it as a lab, I just like to call it as a project, design project. I'll try to send you the template so that every report will look same, and don't even ask me or send me an email like please send me an instruction with how many marks for abstract, how many marks for conclusions. I'm not going to do that, because it doesn't make any sense to me. Why is that? Like, imagine you write extremely beautiful abstract, and if I don't say anything in the design project, how can I give marks just for an abstract? Yeah, like, so abstract is like you compile the knowledge that you gained during the design project, and then you put it on the top of your abstract. So if you didn't gain anything, and then if you manage to write a good abstract, I cannot give marks for that. But I will tell what are the sections that should be included in the project, in the report, but you should do the justice to that. Yeah. think that's enough for about lab 1. And then lab 2, I wouldn't call this as lab 2. So let's call this as lab plus assignment. So why I call this assignment, you are going to make a lot of literature search about process analytical technology. So you're going to mention what are the different type of PAT tools commonly used in pharmaceutical industries. Always remember, keep everything in your mind. So this whole module is designed for the students. They should know what are the type of reactions that they're going to deal in pharmaceutical industries, what are the different type of unit operations that they are going to encounter in the pharmaceutical industry. So we kept this in mind, and that's how this module is designed. So everything, even the project that I'm going to give you, most of them are related to pharmaceutical industries. Yeah, so like so so and PAT tools plays a very big role. Yeah, in you now I don't think there is any pharma industries, any pharma giants at least, like Pfizer, Merck, or Eli Lilly, or other people with a similar status and prestige. They will never manufacture any product without the assistance of PAT tools. You know? So this is a must. If they are going to manufacturing scale, PAT tool is a must. And more recently, people are talking about how to manufacture the products in continuous mode instead of batch. And for that, you must need PAT tools. PAT tools plays a big role. I'm going to make a video about how to use PAT tools in and how to get useful information with PAT tools, and how much easy or how PAT tools make our life easier. I will show that during that lab video, and I will emphasize on that point. And then for this particular lab, so as I said, most of you are going to the industries after once you finish this your degree. So what I'm going to do is like PAT is a really must. If you go to any job offer, you will see people should have some gained knowledge on PAT, and if you have a knowledge with Super Pro design, that's a big plus. So at the end of this module, you can add it in your CV that you have a hands-on experience with Super Pro design software. So you will do this for 12 weeks. You can clearly state that. So university will give you access for 12 weeks to use this software, or even 14 weeks. So you can mention like I have 14 weeks of hands-on experience with a Super Pro design software that not only allows you to design the whole plant, it will also to do some other job like process scheduling, for example. You will learn that using that software. So those are a very big plus. You can add it in your CV straight away at the end of this module. So I have gained knowledge on process analytical technology, and also I have gain knowledge with the Super Pro design software. I know how to do process scheduling using this software, at least the basic skill, or if not essential skill, you can call it as a basic skill. Yeah, so at least you know to open the software, and you know where to go to add the pieces, or how to connect the unit operation. So these are some good things out of this that you will get out of this module. Yeah, I think I emphasized those points clearly. And then and this lab plus assignment, it means like you have to talk about the different PAT tools, and then you have to talk about the working principles, like how Raman spec works, how FT like infrared, how it works, or how FBRM works, how PVM works. So I will tell what are these terms means, yeah, when in the video which I'm going to make. Obviously, if you don't have this COVID situation, I really want to take all of you, but in like in a small groups, like 5 members at a time, to the Bernal Institute, and show the PAT tools to you, and ask you to use the reactor at least for 5 to 10 minutes, or how to switch on the PAT tools, or how to get the data, or how to look what to observe from the data. But at the moment this is impossible for me, and so what I'm going to do is like I will do the experiment myself. I'm going to I will go to the lab, I'm going to clean the reactor, I'm going to put all the PAT tools. So I'm going to list the PAT tools which I'm going to use: FTIR, Raman, UV, and then PVM, FBRM. So we are going to use this to monitor a crystallization process. So I'm going to crystallize probably paracetamol or curcumin. So curcumin, you know, probably everybody is using these days for cancer treatment, and it has many other good properties. Yeah, we also add that in food almost every day. At least in my country, we add. There is, so these are the things we are going to do, and then so during the reaction, I will spike the solution with some impurity. I will artificially introduce some impurity, and then I will monitor in my computer, like using these pad tools, what happens in the solution. Yeah, so these things we are going to learn. These are the things that we are going to learn. So at least you will have some, it might look like a virtual lab, so you will know what are the different pad tools and how they look like. Like I can put a PowerPoint slide, just a photograph, but you should I prefer to show it to you, because we have extremely good lab facilities in Bernal Institute, and I think we are one of the very few universities who have access to all those pad tools all at in one single research laboratory. Yeah? So I want to take these tools to the classroom, so that's why I'm going to do the video, and then I will upload you. And then what I'm going to do, so PAT is not only using this tool. So PAT, process analytical technology, it won't stop. Like you are going to use the probe, like this FTR we can monitor concentration, Raman you can monitor the suspension density, UV you can monitor the concentration, or if there is any chemical reaction, it will get exposed in FTR spectra or UV spike. Or PVM is just a photograph. You are going to take a photograph throughout your experiment. If your crystals are breaking, you can monitor using PVM. And then FBRM is something like if you have 10,000 crystals, FBRM will tell you have 10,000 crystals inside the crystallizer. If you have 20,000 particles, FBRM will tell you have 20,000 particles. And imagine if these 20,000 particles, out of this 20,000, if you have 10,000 particles of 80 microns and 10,000 particles of 50 microns, it will tell some information about that. Okay, 50% are one size, 50% are other size, and their average approximate size is around this much microns. So these are the informations you are going to get through FBRM. So I will show how these tools looks like. They look very compact, really. It's not more than 30 centimeter. Yeah, so it's almost like 1 feet probe. So we are going to use that, and an industrial scale, they are going to use the same type of probes. Yeah, so it's a really good thing. You should know about these things. So I will, and as I said, PAT tool is not about just using these tools and getting some spectra and then using that spectra to convert something into concentration. So PAT tool is also about how do you call, like it will help you to make something reproducible. Yeah, so that's the key behind this PAT. So normally in pharmaceutical industries, if you're going to manufacture some product, they always have this problem again and again. Like one day they put some recipe and then you get 100% purity, and next day you put the same recipe, you get a 95% purity. So that we call it as a batch to batch variation, and we do not like that. Yeah, because then you have to purify it again. It's a lot of job, and we try to eliminate it. Yeah, so those things we can avoid through PAT. So through PAT, it's also like we will build a recipe using the software, and then we can just repeat exactly the same. Computer will memorize everything, so it will switch on your reactor exactly at same time. It will switch off, it will start your if you start at 10 o'clock, it will exactly put your temperature by 1 degree at some point. So tomorrow if you start at some time, so it will exactly repeat the same process. It will precisely increase the temperature, it will precisely cool down your temperature, and then so that everything will be so much precise. All you need is to load or drag and drop the file which you created yesterday. Yeah, so this is one good thing about PAT tools. And then it also allows you to do some chemometrics. Yeah, so I will show you how to do that. I will collect some data, and then I will show you how to perform like a principal component analysis. You don't have to learn the mathematics behind that for this module, but you should know that part allows to do that. So we will perform some multivariate analysis, and then I will convert those spectra into concentration, and what I'm going to give you is that concentration versus time. So you are going to fit some kinetic expressions in that data, and then you are going to talk about the different path tools that we used in the experiment and their working principles, and then how it's converted with software which is used to convert your spectra into concentration, and how we converted it. I'm going to introduce you some calibration free method, so you will learn a lot of good things out of this one lab assignment. A lab assignment I prefer to call lab hyphen assignment. So that way, so you will get how much marks for this? 30.5 marks. So you will get that one. If the report looks complete, every section should be complete. Like there is no point in writing a beautiful conclusion while your discussions is so bad, so it has no meaning. So everything should be properly justified. Only then you are going to get 30.5 marks. So I know some of the students may not have experience with how to write a research article or something like that, but I like to expect that research article grade reports, which means honesty to the core. That's the first thing that we see in the research paper. No plagiarism. We learn everything. What we write in the whatever we put it in our research paper is what we learned, is not what we copied. So if we don't understand one concept, we do not put that in the research manuscript. So that's what I expect from you. So whenever I say this word research quality report, it does not mean that the template of a research paper. It means the integrity of the research paper. So you should be very honesty, loyal to the core. You must read everything, understand everything, and only then you must put it on the paper. And that's what I expect you in the assignment. And when you are going to analyze your results, even if the analysis is wrong, you will get full marks if you provide your honest discussions. So these things I expect. And the deadline is week I forgot. For lab 1 I think I fixed let me check. I think week 10 is enough for Super Pro design, so you can give this by week 11. You take some time, but it doesn't mean like you have to the students always do the same I won't say mistake, maybe they're busy. I have to understand their situation as well. Like whenever I say deadline is week 10, week 11, I start to get email exactly week 10, week 10 Monday, or maybe even week 9 week 11 Sunday, or week 9 Saturday. Like what to do, where to get the information. I prefer you to start immediately. Week 11, if I am going to give you week 11, what does that mean? It's like you need that much amount of time to collect the information, learn something from that information, and then draft it and make it into a complete report, at least readable report. And then try to make it like a same font. Some students, I don't want to blame them. Probably they don't have time to do it in a better way, but you must make it the report very clean, very very clean. Like if you take a research manuscript, everything will be justified or maybe left aligned, and then you will have some nice subheadings which will be bold or italics, followed by some discussions, and then you must cite the references, approximate in the correct places. Say like a crystallization is a purification technique. Commonly used in food and pharmaceutical industries, and then you must put a reference next to that statement, because this is not your statement. It's a statement that you learned from literature. So you have to put the correct references after your statement in your report, both for lab 1 and lab 2. So I'm going to expect this tiny details, and you will get marks for those things, because I respect those type of students who give credit to the information where they get, where they obtained. So these are the things. I think I talked enough about lab 2. So So for this week 11, Friday 6 p.m. This is for lab 2, and your final exam will be 39.5 marks. You are going to expect a few multiple choice questions, and then you're going to solve some problems and few open-end questions. So last semester I was handling 3 different modules, and 2 of the modules, some of the students complained the final exam was tough and the time was not enough. Yeah, and that happens only if you don't read continuously, so you must read. If I upload something, you must read immediately. If you think you can pass an engineering subject just by learning everything in 1 week, it's practically impossible. You might pass, but you will not learn what you have to learn. It will kill the learning outcome. So I suggest you to read. Yeah, at least I will try to send a reminder. Maybe that's the best way I can interact with you. So try to read the videos, try to try to watch the videos, and try to gain the information that you should learn. Yeah, at least if you as I always said, try to use paper and pen and paper, and take some notes. Yeah, like when I talk about ternary diagram, try to draw yourself. Yes, say like solute here, say like a carrier liquid here, solvent here. So if I talk something like that, you must remember it. So why I label them as B, why I label them here something as A, why I label them something here as C. These are some tips. Yeah? This is nothing to do with to how to read the module. It's up to you. You can have your own ways. Yeah? If I draw something like this, you have to draw. If I label something, and then when I during the discussion, I might tell like your fluid, you have some fluid, you are going to do something, it's going to come to this point, and then do something, it's going to go to this point, and do something, it's going to come this point. So try to use the pen and paper and draw with me, and that's the way you are going to pass not pass. Passing is one thing, like you get 60 marks already in lab and assignments. I mean, you won't get it depends on how good you submit, how good your report is. But the other thing is, like, you are sitting in this module to learn something. You must do few things. Yeah, so I recommend you to use a lot of pen and paper. As I said, previous years I write while I talk, and as I said, it's going to be time consuming. And one student, he sent a very different feedback. He said he's so annoyed with my pen sound. The pen, it creates some sound whenever I write, and he found that he or she, I don't know, found it very annoying. Yeah, so so I'm going to write before in the notebook, and that's not a bad idea, especially for chemical engineering topics. Yeah, so and then we will deal with this next lectures through that way. Yeah, I think I covered I think I said everything that I wanted to say. So I will just put some I'll just list them how we are going to assess this module. So final exam, it will be like 39.5 marks. We will get some MCQs, objective type questions, heavy duty problems. Heavy duty problems, whenever I use that word, it means you must have practiced in your home. If not, you cannot pass that. You cannot solve it within the time. Yeah? Your exam will be only for 1 hour and 30 minutes. I'm not going to extend the time, no matter how hard you find the question paper. It will be, you can solve it in less than 1 hour if you practice. If you practice whatever I'm going to solve during the tutorial hours or during the lecture hours. So if you don't practice, you won't understand. Yeah, and you will not. Few students, they complain they couldn't understand the question paper, and that's because they don't understand the concept. Yeah, so if you know the theoretical concept, then you will solve the things very easily. So as a chemical engineer, you should know like even if you don't know the full details, if somebody stated the problem, you should be able to figure it out. That's really a must. maybe this year I will try to state everything clearly in the question paper, and then let's see how it goes. So you will have some heavy duty problems. So whenever I use this word heavy duty problem, I'm going to tell you again and again, unless you don't practice, you cannot touch this problem in the final exam. You can try, but you cannot finish it within the time. Yeah? For that you must practice. Yeah, you should know, okay, this is a liquid extraction unit, this is a distillation unit, I know how the vapor liquid equilibrium, what does that mean by, what's mean by that. Okay, if he asks something like you have some feed with this many percentage of compound A, that many percentage of compound B, and I know how to solve the problem. So I expect that thing. Yeah, for the, so you can do that only if you practice. Yeah, if you practice in the home. Yeah. So these are a bit heavy duty problems, and then you might have something like a fill in the blanks. Fill in the blanks, and then like a, I will even call it like open to debate type of questions. Huh? I'm going to ask you something, you have to answer. You have to give, I'm going to give some statement like I think I can separate a fluid with this much vapor pressure and that much vapor pressure at this temperature, and do you think can you separate these two liquids from that liquid mixture at that particular temperature? You have to say yes or no or whatever, you must, and you must justify it. Yeah? If not, you will get 0 marks. Huh? so try to understand the concepts, and that's more than enough. So that's how, that will be your final exam, and then lab 1 30 marks, and then lab 2 plus assignment 30.5 marks. So don't think that you will get 60.5 marks just like that without the hard work. You must work really hard. Yeah? You must work really hard. You must make a really very good report. Only then you will get the maximum mark. I have really high expectation when it comes to lab and assignments. Yeah. So and always remember that, like I know everybody is going through the same COVID situation. So this assignment is not to stress you, or not to transfer my workload to your side. That's not my intention. So the purpose of giving this lab or assignment is to, first you will get good marks. That's another thing. Apart from that, wait a second, I think I forgot to mention something here. Downstream. Yeah, it's okay. But the purpose of assignment is it also give you some self-learning experience. Like it's not like I can talk about part tools. In fact, I'm going to give a lecture about part tools, but I expect you to do the bit of extra bit of search from your side. Like but honestly, my main intention is to give you will get good marks. Like if you have extra assignments, it will help you to get a good final grade. Yeah, no matter how you perform in the final exam. So for that you must do the justice. So because some of the students, they even feel like it's like we are transferring the workload to the students. It's not my intention or any other lecturer's intention. Like so that's why this time I'm going to put my effort on this side. This both lab, for lab 1 I'm going to teach you super pro design. For lab 2 I'm going to do the experiment for you. So I will do my part, and I expect you to do your part sincerely and honestly. So that way you will get the marks that you will deserve. Yeah. So I think I said everything that I want to say for this lecture. So I will upload both of these videos for you. So it will be uploaded in YouTube. It might take some time to So what the moment I upload, it will be in a low pixel format. I think around the 360 pixels. I don't remember. So after 1 hour, you will get YouTube will convert it into higher definition. Yeah? So full HD mode. So, so I think that's enough. And then, oh, for one thing I forgot to mention, like the first 6 weeks, what I'm going to cover. As I said, we have a heat balance, mass balance, reactor design, a lot of stuffs. But I'm going to start with the toughest topic, which is liquid extraction. Liquid extraction. And then I'm going to go with the distillation. Especially if you don't have an engineering background, these two topics are a bit, it's not tough, but you need a lot of patience and understanding to solve these problems. So if I do this at the very beginning, you will have a lot of weeks to time to study, repeat the problems, look at the videos again and again. Or one thing I will do, which may use your life, is like I can write it very neat, and then I will put some page numbers for each page. So and then I will convert it into PDF. So it might look like a book format for you. So whatever I'm going to talk, I can write it like imagine you are going to load something into your reactor. I can write that. Imagine you are going to load something into the reactor. So that way you might find it easier, especially for non-engineering students. Yeah. So I will try to make that way. So that way you will so the like it will be like a running format. So it will be, when you read the notes, it will be looking like I'm talking to you. So I will try to make something like that. So that way you can learn this engineering subject in a bit easier way. So the first 6 weeks, I will try to cover liquid extraction, distillation, and then I will go to the reaction kinetics. Reaction kinetics, or probably even something like an adsorption for a change. Liquid extraction is tough, distillation is tough, adsorption is bit easy. And then we will come back to another slightly bit engineering topic, which is reaction kinetics. Then we can go to crystallization, agitation and mixing. In fact, I should go with agitation and mixing first, but I prefer to go with the toughest topic first, because it will give you a lot of time to read these topics. You will learn. You have to buy graph sheets, and you will try to plot these images. You have 12 weeks to learn that. Yeah. So before coming to the final exam. So the main intention of going to start with the toughest topic is it will give more time to spend on the tougher topics. And then for adsorption, you honestly, less than 2 days is enough to learn everything. Yeah, whatever I'm going to talk about adsorption. But for liquid extraction and distillation, you need a lot of time to understand the concepts. If you do not have engineering background, I'm sure you might have never used vapor liquid equilibrium data or liquid equilibrium data. So this is something you will learn new, but which means you have to spend extra bit of time to get practiced, to practice again and again. So that's what I'm going to do in the first 2 weeks. And sorry about this bad handwriting. So the next one I will write first. So that way we will save a lot of time, and then it will make your life a bit easier, and also my life a bit more easier. So if you have any feedback or comments, you can tell it to me through email or any other source. I'm not aware of how it works, but you can tell to me directly through email or Teams. If I am not in any other meeting, if anyone calls, normally I take the phone or the Teams. Yeah, no matter, even if I am in the supermarket, I take the phone if somebody calls me in Teams. Yeah, so that's how I did in the previous semester. I'm going to do the same in this semester as well. Yeah, so thanks for listening to me, and feel free to contact me, and we will try to meet once I finish this lecture. So once we are going to the tutorial stage, we will meet. Yeah, we will meet, and then I can help you to solve some problems if you really don't know to use a graph sheet or something. Yeah, I don't know how I'm going to show how to use a graph sheet in paper 2. Probably I will try to buy the smart graph paper, and then I will try to show you online. Yeah. So thanks for listening to me, and I'm going to stop recording the videos now.